Hi, geometry friends. We're in section 13.2, and we're going to talk about probability with permutations and combinations. So let's get started. Permutations refers to the arrangement of things or objects where order matters. So for instance, if I were to select a group of people, let's say I would select three people from our class, and one I was going to label the number one student, the first student, and the second student, and the third student, right? And let's say in our class we had 15 students out of 15. So this permutation, when I talk about permutation, it would matter who's first, second, and third. It would matter because having, let's say, Zoe be first and Eva be second and Charlie be third is very different from having Charlie and then Zoe, then Eva, right? These are all very different scenarios. So a permutation, the importance is that order matters. Order is significantly different. Order refers to a different event in a sense, all right? And the reason why I'm making this speculation is, well, this distinction is because when we talk about combinations, which I will talk about now, I'm going to just kind of skip over. So permutation, basically order matters. And then combinations, order doesn't matter. So imagine the same scenario where we've got 15 students in class, right? And I need to pick three students to work on a project together. If I picked Eva, Charlie, and then I picked Zoe, or if I picked Zoe, Eva, then Charlie, or even Charlie, then Zoe, then Eva, these all represent the same situation. I picked the same three kids. I picked the same three students. And so if I have these other, students here, for me, this represents the same thing. So order doesn't matter when we're talking about a combination. Okay, so that's the distinction between the two. Factorials, you guys are familiar with it. If I had 4 factorial, we discussed this, it means 4 times 3 times 2 times 1, where that would be 24. And 0 factorial, by the way, is equal to 1. That's something we want to just hold on to as a concept. And so the way we write factorials, we would say n factorial is equal to n minus 1 times n, well, n times n minus 1 times n minus 2, all the way down to the number 1. Make sense? All right, I know you guys have seen that before. So we've done permutations, we've done combinations, we've done factorial. This is a new one, circular permutation. So this concept thinks about, remember, permutation is ordering things, is, when you organize or order things when different order matters. A circular permutation is the same thing, but realize when we usually talk about permutations, we're talking about, like I had first, second, third, like kind of a linear situation. Circular permutations refer to changing the order of things that are in a circular ring, okay, such that their order is not preserved. So 1, 2, 3, 4, let's say 5, 6, 7, and 8. I've got these 8 things. And if I were to turn this, the order would stay exactly the same. So how many different organizations can we have of these 8 things is how we would discuss the idea of circular permutation. Okay, now that that's covered, we're going to get into each of those topics in a little bit more detail. If you didn't get it before, here's our assertion of what a factorial is. And factorial is basically multiplying from that number backward to 1 each integer that you have. And again, 0 factorial is defined as 1. All right, so let's take a look at an example. Probability and permutation of n objects. Shanice and Renee are members of the lacrosse team. If 20 girls on the team are each assigned a jersey from numbers 1 to 20 at random, what is the probability that Shanice's jersey will be 1 and Renee's will be 2? So you remember what probability is. It is really the idea of a specific desired outcome over all possible outcomes or the sample space. So what are all the possible things that could happen? Now, remember, there are 20 young ladies and there's 20 numbers. And so the possibilities are basically going to be the first uh, young lady has 20 different possibilities for her shirt. And then the next lady would have 19 because we already picked one here. Then the next lady who would get a t-shirt, if you're pulling it out of a box, would have 18, then 17. You guys see what I'm saying? And then all the way down to one, right? Because that last lady just gets what's left. Now, how would I write that knowing what we just talked about? Well, I'd write that as 20 factorial, right? So 20 factorial is my sample space. Now I need to consider all of the things that could happen. Now, the things that could happen, well, not all the things that could happen, but my desired outcome. I want to know that Shanice and Renee are going to get the numbers 1 and 2 respectively. So if I imagine these ladies again, let's put like Shanice here. Let's say Shanice comes and she picks from the jar or the box of t-shirts or whatever shirts. There's only one way she can pick the number 20, the number 1, and that's to pick 1. So there's only one option for her. Similarly, there's only one option for Renee, right? Because Renee can only, we are only concerned about one thing, her picking that number 2. So there's only one way for her to do that. Now that leaves how many more shirts? Leaves 18, right? Because 2 have been chosen. And so the next young lady, we don't care what she gets. She can have a choice of 18 different shirts. The next one will have a choice of 17, 16, so forth and so on, all the way down to 1. This number here would be 18 factorial. So the desired outcome, the number of ways or the probability of this happening will be 18 factorial over 20 factorial. Well, let's think about it. 18 factorial over 20 factorial really is 1 over 20 times 19. I'm going to let you think about that for a second, and then I'm going to explain. Remember, this is the numerator. Before we did this, it was 18 times 17 times 16, blah, 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 all the way down to 1. And then this denominator is 20 times 19 times 18 times 17 times 16, blah, 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 all the way down to 1. Technically, because all this stuff is being multiplied, I can cancel these guys out. So I'm left with 1 over 20 times 19. So the probability of these young ladies getting the thing they want, particularly Shanice getting a shirt with 1 on it and Renee getting a shirt with 2, will be just this: 1 over 20 times 19, looks like 2019, 1 over 20 times 19, which is going to be 1 out of 380.